Today I'm going to try to solve some Leetcode problems. I was watching this guy streams here yesterday and he inspired me to try to solve some problems today. Probably not gonna be able to do any of them, so I'm gonna do, because I suck at Leetcode, so I'm gonna do half an hour for each, and then if I can solve, I'm gonna look at the solution. And I'm just gonna try to do random problems. So let me go to the problem first, then I put the timer. And I hate doing Leetcode, but I think I want to improve at algorithms. And the idea that I have is to, on the other project that I'm doing, which is a software code visualization website, the idea is to do something related to Leetcode eventually. Like I'm trying to think about a way that I can parse code to, like, the idea is to get a bunch of Leetcode solutions, which I already have here, and then try to see if I can get patterns from them and display on the visualization. So eventually, obviously, I want to become very good at algorithms, but I was thinking more about doing this stuff here first, to start to see. But I think that is probably fine too, because the thing is, I hate doing Leetcode. For the way that my mind thinks is kind of really annoying to do it. But I'm gonna try to get out of my comfort zone and then try to solve a bunch of them. Because I know if I solve enough, I'm gonna become good eventually. But it's just annoying, like, in the beginning, so. Yeah, I got all these Leetcode solutions here from a bunch of GitHub repositories that I searched on GitHub, obviously. So later, I'm probably gonna try to do something along those lines. But for now, I think it is fine to, I changed, I have to work on this again to show the graph. It's probably, I don't remember where I stopped here. Yeah, I need the server, but whatever. So this is the one I'm gonna try, and yeah, let's put the timer. I'm just gonna try random ones. Longest subsequence repeated k times in string s. So I have a string s and I want to find the subsequence repeated k times. So that means that the minimum length of the subsequence, that should be k, I think. No, it's repeated k times. Yeah, that should be the longest subsequence. Damn, that seems like it's really hard. So let me think about it. And the other thing that I'm thinking about is that I should just try whatever, like, I can think of, instead of, because before, when I tried to do these problems, the way that I was thinking about, because this is one of the biggest challenges that I have, and I still couldn't figure out, because it's not how you solve the problem, it's how you think about solving. So obviously I have some habits based on the stuff that I did on the past, the stuff that I built, because I'm self-taught. So, like, I know that the way that I think about how to solve them are not optimal in the first way. So the way that I was used to thinking is that I'm gonna try to do this method or this other method or use this other data structure, like that for search, because I know that's most of the solutions are like that for most of the time. But I think now I just want to try to see, like, what comes to my mind and how do I think about solving without focusing on any other stuff, just with what I know, and then maybe searching for stuff. And then I think I'm gonna try like this. And this is the thing, like the thing that is annoying to me is that I don't think that's a very good method to learn, because I'm just gonna be reinforcing my habits, or like I don't know how to go from the habits that I have right now to what is the optimal way to think about. And that's the stuff that I'm trying to build on the software visualization thing. But I think for now I'm just gonna try to see if what I come up with. And then even if I don't get better, then it doesn't matter, because later on I can just focus on this stuff, and then I can, I have to spend time thinking about what is the best way to go about changing the way that I approach the problems. So the way that I'm thinking right now is that I should probably have some separate thing to put another string, a substring, an array, or another string. And the thing is, I don't know the methods very well that's I should use. So what I'm gonna do is just write pseudo code and see. Then later on maybe use ChatGPT or go to the documentation to see if there are any methods to do. I think in Python strings are immutable, so. But I'm probably gonna have to break them down into an array and then to a string again. So maybe this could be maybe a set. I think is not very good, because the string can be repeated, I think. So I think the first thing that I have to think about is what are the heuristics for the substring. Can it have double characters? I think obviously the one heuristic is that it has to be the longest. So I guess the first thing is like find all the substrings. The thing is that I think that's not probably the best approach, but like I said, I'm just gonna think about the brute force way first, if I can make that happen, and then I worry about if I can optimize. So first I have to find all the substrings. So the question is, what is all the heuristics that make a substring? Because you can have like any pattern at all. So maybe it's just when the substring is repeated, but then would that mean that the D, for example, have a string like this? Is D a substring? Or is DJ another substring? And then like, is all the other patterns a substring? That's the question that I have in my mind. Longest subsequence repeated k times. So subsequence, not substring, but pretty much the same. By deleting some or no characters without changing the order of the remaining characters. So the thing is, you can't change the order. Yeah, that makes sense. So like for example here, you can do H then J and then D, or H then J. It has to be J and H. So that makes sense. It's repeated k times in the string as if sequence as k is a subsequence of s, where sequence times k represents a string constructed by concatenating k times. Trying to see if I understand what this means. Is repeated k times in the string as if sequence times k is a subsequence of s. So obviously I think what they're trying to say is that if you multiply the substring by k, which is the amount of times, then it's still existing as. So for example, d times k. Yeah, but that's the thing that is kind of confusing. So d would be a substring, and then here would be 4 d substrings. So what they want is the shortest substring that is the most frequent one, I think. No, it has to be the longest. Because otherwise you would just count the letters. Limiting. Yeah, so it's a relationship between frequency and the length of the strings. So it's frequency versus length. Because you can have a string that is very short, and then the odds are that it's going to repeat more times, but then it's not the longest. So that's the calculation, I think. So I think the first thing that I have to do, the first thing is how do I check to see if, like, what is the parameter to see if something is a substring or not? I think anything that is like lower than the string itself is a substring. So it's about... Yeah, but then how do I check all the possible patterns? I think that's the challenge. Because if I decrease by 1, for example, if I go to from the left to the right, just do a loop, and then I decrease, and I say that the substring is whatever. Like I can split the string, maybe loop split, and then I have this substring, or whatever method to separate, and then. But then how do I... Maybe I need a dictionary to cache everything? Yeah, let me think. Like one thing that I could do, but it obviously would be inefficient, but I think is probably a path to solve, is just get all possible combinations inside of the string and then put it on a dictionary. I can put it on a counter in Python. So counter is a dictionary that counts the frequency, and maybe that solves. No, let me think. How would I accomplish that? Because it has to be... That's the challenge. What I'm struggling now is just thinking about like how I'm gonna make sure that I have all the possible combinations. But maybe a dictionary. Yeah, but if I have a dictionary, how do I do it? Because I can loop from the left to the right, and then I can subtract one character at a time and then create a substring. But that doesn't make sure that I have all the substrings possible, because you can have substrings on the middle. So this example only gets... So the question is how do I make sure that I have all possible combinations? Oh, this also kind of confuses me because the way that I was thinking about is different. So I think I don't understand very well what they want. Because the way that I was thinking about is that you can't change the order. So In my mind, you should this string here shouldn't be a substring of this one because there is no sequence there. Yeah, that doesn't make sense for me. Oh, so if you put them together. Damn, that's fucking hard. Either two combinations. Yeah, I'm not really sure. I'm trying to understand more the problem first. So, like, I don't understand this example very well. It's like, first you get the substring, and it doesn't matter if they're separated by characters, which... And then from that substring, you have to get the other substring. That doesn't make sense to me. Oh, okay, so it doesn't matter. I think it doesn't matter like where you delete the characters, as long as you make another string, which makes a lot harder as well. So here, for example, I can build any combination that's like I can just delete characters in the middle, but I can change their order. So I'm just gonna ask ChatGPT. The thing is, like, this is something that I want to do as well. I'm gonna ask ChatGPT how to do it, but I want to break down because I don't want to rely on the libraries. So if it does tell me like choose combinations or product or any of the itertools library or other libraries from Python, I'm gonna try to ask how would you do that with the simple data structures, because I don't want to rely on the method. So and I don't care that much that this is kind of cheating because the point here is to learn. So I don't like. I'm more concerned about becoming better at thinking about how to solve the problem and understanding what is the blocks that I have now. Itertools, yeah. So just doing a nested for loop. And it's one character in front of the other. So this one starts at the 1 index. And this one starts at the 0, probably. And input string. But I wonder... Like, this is another thing that I don't know, because... Like, how do I become used to thinking about the methods myself? Because if I do this all the time, maybe I'm gonna memorize eventually, but the concern is that it's just gonna become a crutch, because then I'm not thinking about how would I do it. So maybe it's better to just... Yeah, ChatGPT, sure. Okay, so, but after you get the substring, so first thing is get all the combinations. So I'm just gonna put the sequence here. I'm gonna break down the problem in multiple sections because I think that's gonna make it easier to find the solution. So get all the possible combinations, substring combinations of the S string. Then maybe I should put them on a dictionary, I think. Then what do I have to do? So you get the substring and then you have to get the pattern inside of the substring that repeats most often. Or I think it doesn't matter, like it doesn't matter if you get, I think it's probably gonna involve recursion, I think. Because they're saying that it doesn't matter how do you build the substring, or it can be from like how do you get the pattern? What they want is the longest pattern that is repeated inside of the thing. And you can build a pattern however you like. You can delete as many characters you want to build other substrings. So after I have all possible combinations, then you just have to count. But then because that's the thing, how do you classify? Like, does it matter? I think after you get all possible patterns, then it should be already solved. The question is just how do you... So I have to break this down more. Because it's how do you get the patterns? That's the challenge. Because if I'm able to do this, then like this would include already the process of deleting the characters in specific ways. I guess that's the whole thing, the whole point. Then after that point, it should be easy because then all you have to do is just count the frequency. But it is really hard though. Return the longest subsequence repeated k times 3. If multiple such subsequences are found, return the lexicographically largest one. Damn, this is even harder. So I guess this probably means that it is on some order because the strings are converted into numbers. So it's the one that has a... So I can create a dictionary, like, I think that's the easiest part. Because you can just map based on the... Like, create a string of all the possible alphabets, and then you just put A, B, C. I think that's all of them. And then I just loop over and put the values. The values will be the index, I think. Yeah, whatever. So let me focus on the other one. So if there isn't, you return empty. So, like, obviously this condition is gonna be here, I think. If the length is 0, you return this. Because if there is a string, then there's gonna be at least one. Damn. Oh no, it matters. The K matters as well. So maybe this is wrong. Yeah, I'm gonna worry about this later. I'm gonna try to solve the other part first. So it has to be repeated K. So I think that's, yeah, the first step is to get all the possible combinations. Then after you do that, you have the frequency. Because it's just gonna count the combination. But the problem is, how do you count it though? That's the thing. Because if you have the combination based on the substring, then the counting is gonna be based on the substring, not the original one. So I'm thinking that it's probably gonna evolve. There's some recursion because that's the pattern. So like after each time you break the string down, you should count patterns inside of the substring. So like there's a meta problem here, not a meta problem, but like there is an essence here that I think you have to capture. So you're just like breaking the problem down, and each level you're counting. But I'm not really sure how to go about doing this. Because the problem is, like, how do I make sure that I'm capturing all of them? I think that's the biggest problem. It's like one thing that I can do. And do this. So here, I think that, like, I should have an algorithm here inside of this one that it checks to see all the patterns in the current string, which would be the main one. And then I put it on the cache. Then after that, when it calls itself recursively, there's a branching that happens. I think that's how you solve it, probably. So you branch based on different conditions, but then the question is how to make the branches, I think. So the way that I'm thinking about it is that I'm gonna pass the first string here, and then here I'm gonna like find all substring or current string. I create another algorithm here, and then based on these ones, I check to see if they are on the dictionary or not. If they are on the dictionary, I increase the frequency by 1. If they are not, I just remain the same. And the question is, how do you find it? Because this is part of the recursion. Because if I do something inside of here that says, for example, I think the key, if I do it this way, I shouldn't delete here. So on this one, I don't delete any characters, and on the main one, I do. Because on this one, I just want to find the patterns on the current string. And then here, I'm deleting the characters to find other substrings. So the question is, how do I count the repeating sequences of characters? The problem is to, maybe I don't need to delete, I can just keep a track. Okay, yeah, I'm gonna do it like this, and I'm gonna So let me... I'm trying to think about if I break down the other one or if I start working on this one. But I think this way probably it is a path to solve, maybe. So yeah, I should return here. Let me just write what I'm thinking about, and then I write the rest. So keep track of character in string and start counting. So like for example, I can, let's say this string here, I can loop over the string, then I can get first this character, and then based on this character I check to see if there are any other characters like that, and every time that I encounter a character like that, oh, the thing is I have to keep track of the length of the string as well. So it has to be not a nested dictionary, but I can put a dictionary. Yeah, but it has to be a nested dictionary. Because I need to have the frequency that the string repeats and the length of the string. So it's going to be a nested dictionary. So here, for example, it's going to be the pattern is the key of the word, and the value is a dictionary that has the frequency and the length. So yeah, and then outside of here, I'm gonna put the pattern. Oh fuck. So I think I'm gonna look at the solution. So because I said half an hour, but I kind of wanna see, wanna try to solve it because I think I have a path to do it. Maybe I'll try to solve for more time. I'll try to see if this works because I'm curious to see if it's gonna work. And then if it doesn't, then I'll look at the solution. The biggest priority I have is to like become... I don't even care too much about solving the problems. I'm more concerned about as I do the problem, like having the awareness of the way that I'm thinking, and then trying to break down like blind spots that I have, or like habits that I have in the way that I think on how to break down the problem and solve it, and compare that with the solution, and then try to reverse engineer the thought patterns that they had to solve the problem, because that way I'm gonna be more aware of what kind of habits I have when I think about the problems. And so obviously the downside that I see with this is obviously that it's going to be very slow. Because if I do it like this, I'm going to have to... Like, for the way that I'm thinking about it is that I create like a... First I get one, like I do it based on the length of the string. So first I get the length of one, or length of one. Then I count that pattern inside of the string. Then I get the length of two. Then I count that pattern. But if I do it like that, then the problem is, like, not only I have to start from left to right, but I have to get the other strings that are possible combinations that are on the middle of the string. And that's the issue. But I think the idea here is probably... Like, the direction is probably correct, I think. So, but what I would do after is just... So like once you find all the possible ones and put on the dictionary, then you have the frequency and the length. Then here is about all possible deletion combinations. And here is about deleting characters from the main string to find other substrings. So it's gonna branch off into if-else conditions here, I think. Or another algorithm. And then I just call this one recursively with the other one. And then I need to find like base condition which probably would be that when this stuff is empty. So like from this, after you break down, gets remaining string. Then when the length of this is empty, you just return. And here, find string. Yeah, so now it's about how would I solve the other ones. I'm curious to see the solution though. Then obviously after you do all this, then you can use the dictionary to find the best combination. So first, yeah. I think you just multiply the length by the frequency when you get the highest number. It has to be k times. So the frequency is equal, so you filter the dictionary based on the k for the frequency, and then you get the longest, which is going to be the max of the after you filter. So I think the main thing that I want to figure out is this thing here. So the question is, what is the best way? Yeah, this is the question. So I'm gonna spend some time thinking about this, and then I'm gonna ask ChatGPT, and I'm gonna look at the solutions. But I wanna think about like how would I go about doing this without any methods. So like the thing is that I know that there is a block in my mind, because and it's kind of hard. This is what I'm trying to clarify, because it's hard to grasp what exactly. I think the issue is that I can't define very well like the boundaries of the problem, like, because in order to solve that, I have to think about all the possible ways to combine strings. And I think this is the issue that I have with the way that I'm thinking now. Is that I'm thinking about, like, there must be a way to think about this that doesn't involve, it doesn't require thinking about in your mind all the possible ways that you could capture like a substring. But maybe that's the only way. Because the way that I think is that I have to think about all the possible ways, because I want to create heuristics, and then after you create heuristics, I can create the code. Well, I think part of me thinks that that's kind of bad, because what if you have a situation? I think this is the issue I have with recursion. I think that's the fundamental issue. So the problem is that if you have a situation where you have, because recursion, and I think most of the complex problems are going to be a fractal pattern or a multifractal pattern. And what you're trying to do when you solve a recursive problem is finding the multifractal pattern that solves the problem. So I think this is the main issue here that is going on. Because in my mind, the natural way, I think, and also I think for everyone, the natural way to think about a problem is you have to think about all the possible ways that you or maybe not all the possible ways, but a lot of the ways that something could happen for, so in the case like that you can get a substring from a string, and then from that point you create the heuristics. There are gonna be the if-else statements and all this other stuff. But the issue with the recursion is that you can have a problem when with the recursive approach. You're trying to think about like what is the essence of the pattern itself, not all the possible situations. And I think that's a much better way to think about it, because it allows you to solve. But then the question is like, how do you find, what is the process of thinking that's going to allow you to find that fundamental pattern that doesn't involve trying to reduce the complexity into the archetype? So let me think about this. How, because I know there's something there, because like I've been not seeing, it's kind of hard to, like, I have the experience in some of these problems that I can think about like on the recursive way of, because there are like a couple of principles I think. Obviously one is the base condition that you need to have to stop, and the other one is the branching. So there's the base condition and the branchings that you're gonna do, and then based on the branchings you're gonna create the structure. But the question is like how, because I think this is gonna be always, this is always gonna be the challenge, which is that the pattern is always the same, but then it's gonna change on the conditions you have here. So from problem to problem, the only thing that's gonna change is what conditions you put here. So the question is, what makes the difference between them, I think. This is one part, and I think the other part that I'm weak is on thinking about what patterns, what methods I can use from the language. But yeah, I want to find an approach that allows me to think about the data structures themselves without any methods, because the methods are gonna like they're gonna simplify, but then you lose the complexity. I want to like become better at understanding in the fundamental level how it works. So let me spend some time thinking about, I think spending time thinking about this stuff is a lot more, it's a lot better than trying to solve a bunch of problems. Because if you're trying to solve a bunch of problems, you are gonna become good, but then it's kind of inefficient, I think. It's much better to just think about how can I solve any problem? Like what is the problem with the way that I think about things? So that's why I think it's worth to spend more time thinking about this sub-problem here from this problem. So the question is, how to get all possible substrings from a string? So I guess the first thing that comes to my mind is, but I'm not really sure if it is kind of the thing that I just said, where I'm trying to create heuristics, but that's how it naturally comes, I think. Because you need to define the boundaries of something. But I think that's slightly different than trying to figure out every pattern, but it's kind of the same, to be honest. So the way that I naturally think about is, when I ask the question in my mind of how can I find the substring from the string, is like what does define a substring? How do you know you have a substring? That's the first question that I think about. And I think obviously the reason why I think about this is because without knowing how you can define it, like the boundaries, then you can't have the solution. Because then you don't know what you're looking for. But I think that's slightly different than thinking about all possible ways to get a substring, because that's the more general thing. So I think from that sense, I think it's fine to have heuristics, because you need to define the boundary if you want to find the thing. So I think that's fine. But the thing that I think I can improve on is on the way that I think about how to find, like, yeah, how to break down the thing based on the boundary. But maybe they're related. Hi. So, like, how do we define this string? A substring. So, based on this problem here would be any pattern, because I'm already not counting the deletion of characters and the reordering. So I think is any pattern that has a lower length than the original pattern, but it has to, yeah, I think that's the main definition. But the key is it doesn't matter where you start or where you end. I guess it has to be either, it can be anything, obviously, as long as it has the length of the string, the original string. But what can change is the boundaries that you go. So the fundamental thing that is happening here, I think, is that you have a boundary. You have two boundaries, which is an array. And then you're trying to find all possible slices of that array. And the question is, how do you go about finding all the possible slices? And I think this is why it's probably recursion is the best. So the question is, what heuristics would create what branching inside of the recursion would allow to make sure you're getting all possible slices? I think that's probably the best way to think. I'm fine, man. And you? And I think this is something that is gonna happen a lot. So I have to think about. I have to clarify this, I think. I don't even care about the problem anymore. I think once I clarify this in my mind, maybe I'll use ChatGPT. I have to think about, maybe I should do another file here on, I think I have one here. Because what I want to do is just run the code to see. This is what I'm gonna do. I think this is a good idea. I should do this manually. Because the thing that I'm trying to do with the website eventually is to do this thing, but automate it. So I think that doing this is probably the best approach. So instead of like solving a bunch of problems, the way that I was thinking about doing, the question that I'm gonna ask myself when I solve the problem is, what are the fundamental patterns that this problem has? And then I'm gonna try to structure my thinking in a way that allows me to visualize the pattern in the problem. I think this is the smartest way to go about it, I think. So what I want to do here is put the, how should I do this? Because I don't want to put based on the, I think I have to name the file something that is gonna allow me to remember the pattern. Maybe just put substrings on a string. So what I'm thinking about doing is just creating a file for each pattern that I think about. So obviously one of them is going to be recursion. This other one is how to find all the possible slices within a slice. And the other thing that is, I think this is the fundamentals, is like understanding the data structures very well. And usually the ones that are going to be used are going to be a heap, which is like a tree. And then you have possible different ways to order the heap. We have a max heap and min heap, I think. And both of them, the difference is going to be the way the value of the nodes in the way that they are stored on the tree. So I think, I don't remember really well, but I think the min heap, the minimum value is at the top as the root, and the max heap is at, the max is at the root. Then obviously you have the queue, which is used all the time, and the stack. So queue, stack, heap, and then recursion, I think recursion is not a data structure, but obviously it's another fundamental thing. So I think what I have to do is just break those things down and then think about like the essence of the algorithms. So what are the fundamental patterns that are going to show up on all of them? And then ask myself how does the variance of the data, which is the problem, is going to change the structure of the algorithm. And then the goal is to clarify how do you go about going from the template of the problem, which is the archetypal structure that every problem is going to have, and then understanding how, like, what is going to be the variance, how the variance in data changes the structure of the code. Because the main thing that is going to change on all recursion problems, you're always going to have a base case, you're always going to have branching conditions inside. Sometimes you're going to have a cache outside. So the question is, like, going from that template, obviously the difference between problems is going to be on the types of recursions you make, and on the types of branching conditions you make, and how many times you call the function recursively, and what happens on the conditions. And that's going to be directly, it's going to be directly a consequence of the data, which is the structure of the problem. I think it's probably a good idea to do this. Because this way is much better. Because it's gonna go hand in hand with what I'm trying to do. It's gonna help me clarify. Because the idea that I have on the other projects is gonna be to parse a bunch of codes. So I'm gonna create a compiler, or it doesn't need to be a full compiler, but a parser. And then from the parser, I'm gonna try to extract fundamental patterns, and then highlight the variance in the data and how it changes the structure of the code. It's pretty much the same thing that I'm doing here, but I think doing it manually first is gonna allow me to clarify my mind on what possible ways I can structure the compiler. Because now it's getting very clear on my mind. Yeah, of course. What do you want to suggest? How to solve this thing or the problem? And another thing that I'm thinking about is that the combination of all possible problems is just gonna be, because that's what the mind naturally does, and people naturally do, is that we break reality into concepts, and the concepts itself is the reflection of the computation of the network of human beings. So it's the same thing that I think is happening with computers, because I think human beings are biological computers. So like what you have is like infinite data, which is infinite potential, and then over the process of computation, it becomes concepts in a network. So the tendency for human beings is always to categorize things, and that's the difference we find, but in reality everything is the same. So we separate things in, for example, math and language and all these other categories. I think the same thing happens here on the algorithms, where you're slicing everything, you're separating everything into categories. So like dynamic programming or graphs, trees, the other types of problems. But in reality, everything is the same, and obviously the computer doesn't know the concepts. So the solution to all problems is going to be a combination of all the possible main fundamental ways and the variance of the data. So this is the main fundamental relationship, I think. The variance of the data determines the structure of the code, which has fundamental patterns because that's gravitational force. And the combination of the fundamental patterns is going to create a data structure that solves that particular thing, because everything is a data structure at the end of the day. So I think the best thing to do, the most efficient thing to do, is to, one, figure out what are the fundamental patterns and like clarify that more, and then from that clarify how the variance of the data is going to change the fundamental patterns. Yeah, I'm not really sure. It just said how to solve the problem. You want to suggest how to solve this one? Go ahead. Obviously, the other thing that changes here would be the type. But the thing is that the type of the data structure is only going to change, but it does change the algorithms though. Because you're going to have to use different methods on the language. So if you have like an array of strings, then the mechanism you're going to do to find the thing is different than you have. So I guess that this is another thing. Because the way that I was thinking about is that the string is just going to be an array. The way that I think about it. It's the same pattern because we're just going from left to right to loop. That's why I thought about the array, the boundaries of the array, and then finding all the possible slices. But if you have an array of integers, then it's going to be different. Yeah, because in this case, it's not going to be that much, but I think that's obviously it's going to matter because in some situations you're going to have algorithms that the purpose is to sort the array, for example, or to do binary search, and then it's going to depend on the type of data structure you have inside. So there's also this relationship between the data structures and the way that the algorithm is going to be. We can use binary search to find all the subsections, all the slices within the array. I'm not sure if binary search would be good for that. Yeah, of course. He's asking if he can ask something not related to this problem. I actually prefer much more to study this way, I think. It makes a lot more sense in my mind. Like, I don't care about the problems that much. I care about structuring my thinking, so I can solve any problem. That's what matters to me. So I want to find the patterns and then clarify the patterns. And I think for this problem here, binary, like, for finding all these possible slices in an array, I think binary search is not very good. But maybe I'm wrong. Let me just do a string of numbers. I think I'm gonna ask ChatGPT as well. But first I'm gonna think a little bit about this, and then I'm gonna ask ChatGPT. Yeah. But if you know, or if you have a suggestion, even if it's not efficient, because I think that the brute force solution is better to go for first, then think about optimization. So the first thing that comes to my mind is that I need a cache or something like that. Because obviously, if I'm gonna find all of them, I need to know whether or not I already searched for one pattern. So I think that this goes hand in hand with a cache. I don't see a way to make it happen if I don't have the cache. but maybe I'm wrong. So I guess the question would be is, so I think I'm gonna break down into these questions because then I can use ChatGPT or search online, but probably just use ChatGPT to see what it says about it. But maybe not. Maybe it doesn't matter because I wanted the slice, not I want the slice, not the pattern. Maybe it doesn't matter. So I think one thing, maybe the cache doesn't matter because I'm confusing the patterns with the slice. So one thing that I'm thinking about is just that there's gonna be the relationship of length and frequency. So I think for each length there's gonna be windows of slices. So yeah, it's gonna be length. So obviously, I think this is the main fundamental relationship here. So obviously, the highest length is the lowest frequency. They are inversely correlated. Because if you have the length of the array, it's just going to be one thing. If you have slightly lower, then it's going to increase. So it's going to combine. So the question is, on a length that is lower than the array itself, how do you make sure that you get all the possible combinations? And then once you solve that, I think that then is either recursive or a loop, because then it's just going to be the same pattern. So I think the fundamental pattern is for any array that is smaller than the original one, how do you make sure that you got all possible slices of that? And I think it's going to be probably shifting the thing left and right. But then, yeah, maybe just shifting to the right. Yeah, maybe just shifting to the right. Or looping over the right. Sliding window technique. I'm not really sure. The thing is, not sure if we're here, but I just talked about this. With dynamic programming. Function should check if a subsequence of length can be repeated k times. Yeah, the thing is that I don't wanna, because I tried to do it like that. Like, I think that's all these categories, they cloud your judgment. They make a lot of sense, but they cloud your thinking, because I want to detach the way that I think from the categories, because the categories are human made. So like it's a projection of people deciding where is the boundary of a problem, which does make sense. Like I don't think that they don't make sense, but I think for myself, when I'm trying to learn, I don't want to be attached to these things, because then it's just gonna make me think in a certain way already. So like, I don't want to memorize like the sliding in window technique, for example. I want to think about how to solve the problem, because I think that's going to allow me to have more creativity, and also to think, also to become better at thinking. So that's what I'm trying to do. And if I just use the techniques, I think it's just gonna, I don't want to worry about that. I just want to focus on what is the fundamental thing that I'm trying to solve, and why do I think the way that I do to break down the thing, and if it is the best way or not, and then how can I move to the best way. So if you're just thinking about, forget the categories, forget everything. If you're just thinking about like using the fundamental structures you have, how would you solve the problem? That's the question. The biggest question I have now is that, like, so once you have a length that is smaller than the full thing, then what I'm thinking about is that, for example, I have these numbers, like this would be one slice that is from the length, and then I can do to get the other slice, just shift to the left. So I create a slice that is the length, whatever the length is. So for example, I will loop over I'll loop over this, and then obviously maybe it's better to put the range, choose a range, and then because I want to do it based on the length, so maybe range is better. And then I go like I decrease the length. Let me think. But the main question is, once I have a length that is smaller than the array itself, then what I can do is just count. But I do need... Maybe I don't need a cache, let me think. Yeah, I need a place to put the patterns, but it's not necessarily a cache to... It's not a cache to make sure that I'm not repeating, I think. It's more a cache to put all the patterns that I have so far. Because that's what I'm trying to achieve, obviously. So I think I need a cache, a place to store the patterns. But let's say I have this. The problem is that the data structure is gonna... But let's say I always have array, because then I can break down anything into array, like I convert into an array. Obviously not, like depends on the data structure, but I'm not gonna worry about the other stuff. I'm just trying to focus on this one, this fundamental pattern. Then I think about the other ones. The problem is that I can't have... So maybe the thing would be length, the key, and the... but then would be a list, or what would be the best way? So I can have for each length, I have I have all the possible patterns. Maybe it has to be a list, I think, because I can't have the list as a key itself. So yeah, I think that mapping the length. So I start obviously with the length of the whole thing, then I append the pattern to the list. Then for the other ones, like as I decrease the frequency, I just... But this is the question that I don't know. If I just go over to the right one time with that length, and then I append, am I gonna repeat the... or am I gonna capture all of the possible ones? I think probably yes. It should be... Maybe I'm overcomplicating in my mind. So maybe it's just a matter of decreasing the length and just going over to the right. But I'm not really sure if that's the best. And then every time you go over, you just append or you just push. So the main question is what's the data structure here that is going to be the best to keep all the other ones. And I think obviously it's going to depend, because then if you have like array strings that you can join, and then you can just save as a string. And but if I just have the array, let's say. But I guess this is one of the challenges, is just that the variance is going to be on that, and it's going to change the way you solve because of the methods, which is going to change the data structure. This is my approach. We will create a DP table. What is a DP table? To store info about subsequences that can be formed from the given string s. We'll use bit masking too. Create a DP table. Formed from the given s string. Initialize. So how would you use bit masking? And the table, I think that's the approach that I was thinking about as well. Initialize the DP table. DP where DP mask will store the length of the longest subsequence represented by the bit mask. Yeah. I think that makes sense, but I was thinking more in a different... But obviously, it's probably the better way you're recommending. But the thing is, I don't really care, man, about this problem anymore. The thing I care more about is the patterns. Is this problem here. So, like, what I'm gonna try to do is just break down into... Every problem that I encounter, I'm gonna try to break down into fundamental patterns. And then from the fundamental patterns, I'm gonna try to reconstruct, like, if I can create a, yeah, if I can create like, imagine I have a bunch of files here, and then each one has a fundamental pattern that I thought about. Then every problem that I approach, I can think that, can I use something that is on the fundamental patterns, and how would I combine them to solve the problem? And then from that process of the feedback, I think that's much more efficient to learn everything. Because then eventually what's gonna happen is it's gonna clarify in my mind the gradient between what is fundamental and what is always changing, and it's gonna allow me to clarify what is the best way to think about solving all the problems. That's the idea that I'm trying to go for. Math problem? Interesting. This one? I think everything breaks down to math, right? Because computing is mathematics. It's pretty much the same thing. You have functions, you have loops. Computing is mathematics with logic combined, but I think at the end of the day, it's fundamentally the same. B and C, I'm not really sure what that means. I'm gonna go to the bathroom real quick. Have to piss. Be right back. Permutation and combination. Yeah, that's what I was thinking as well. It's like combinatorics, right? I think that's what it comes down to. So there's the relationship between length and frequency, and then this inverse relationship. And to get all the possible ones is the area on the curve, I think. Yeah, sure. I think that's the fundamental thing that is happening. So the function is gonna represent the area on the curve, which is gonna be based on the relationship on the length of the array. Maybe we can plot this on a graph as well, and then generate data to see. That would be interesting. I don't make money as a programmer. No. I'm just self-taught, and I dropped out of college to play poker, and then I learned how to code myself. But yeah, I don't have a job. Yeah, man. I think it's especially this time on the markets. Yeah, it's pretty tough. And I wish I could say that it's gonna get better, but I'm not really sure about that as well. Because AI is gonna break everything, so. I think the best thing you can do is just build stuff. That's what I'm doing, right? I obviously I think it's the best because I'm doing, but I'm not really sure. Like I can't think about any other like approach. Yeah, I wouldn't do that if I were you. It really depends on their situation. But the thing, like, college does suck, but it is like because of the way that the system works, it does increase your chances a lot of getting hired. So, but it is like kind of garbage, but it is what it is. Yeah, that would make a lot of sense. If you can get a job in the US, then obviously. I think I already asked. The problem is, like, depending on the way you ask ChatGPT, obviously it's gonna change the answer a lot. So I'm gonna ask in a couple of different ways, and I'm gonna try to break it down. But I think that the bottom of the thing here is that it's a relationship between frequency and length. And to get all possible combinations, you're getting the area under the curve, which is gonna be a graph, because obviously the higher the length, the lower the frequency. So one thing that I want to know is the shape of the graph, and the other thing is once you get all the stuff, you need to store somewhere, obviously. And I think the way you store is going to depend on the data structure. So I think this is the fundamental thing that is going on. So what I want to clarify with ChatGPT is how do I get there under the curve? And obviously the way that I'm going to ask questions is going to change a lot, the output. So if I ask questions related to Python, I think it's just going to give me some answer like this. So I have to find a middle way that allows me to get the answer from Python, but at the same time get the fundamental thing. That's what I'm thinking about now. I'm probably gonna restart this thing. I'm just gonna ask from Python first, so then I try to ask more fundamental. So the way that I'm gonna ask the fundamental is just by breaking down. I have to clarify more, like how do I make sure that this is probably a question that I'm gonna ask as well. Yeah, I kind of like I know the syntax obviously, but I'm not good at all with C. I was like not that long ago, I was trying to create a graph from a compiler in C. So I did a course on how to build a compiler, only the module 1, so it's not the full course. But then I studied the code a little bit, and I was trying to create a graph out of the process of the lexers and the tokens and the part, just the lexers, I think, for now. But obviously, eventually, would be for the parse and tokens as well. But then I stopped at the point that I had a segmentation fault problem, and then I had to solve other stuff. Then I went to solve the other stuff, but I think eventually I'm gonna come back to try to solve the. It's a lot harder than Python and JavaScript to figure out what's wrong because of the debugging. And so it just uses, that makes sense. I was overcomplicated. But because maybe then you can use the, like you can do another thing to loop over this one, and then you can just get the length and the frequency. So like for, yeah, you loop over and then you get a condition that for, so you create a dictionary with the length and the frequency. So maybe that's an interesting thing to do. So I'm gonna ask, obviously, if there's a better way to do it than a nested for loop. First, let me try to understand. So here it goes from the beginning to the one before the beginning, I think. Or maybe not. I don't get why. Maybe this answer is not correct. Because this one is always going to be one ahead of this one. But I don't get like how that would create all the possible slices. So I think the best thing to do is just run and see what happens. What parts? There's a slight delay on the thing, I think. So what part do you want to know that I'm thinking about? I'm gonna have to create a virtual environment. Just thinking the slices within array. Yeah, what I wanna know is how to get all the possible slices within this array here. So we have an array. So I want to find the... first, what I want to know is how to get all possible slices. And then what I want to know is the relationship between the frequency and the length. And if it's probably always going to be the same, right? The only thing that is going to change is the length of the main array. But the relationship is always going to be the same. So I want to maybe I want to plot on a graph what happens, like the smaller the length, the higher the frequency of the subarray, because I think that this is the essence here that they're trying to capture. And then like what they're asking is, how do you find the, like get the frequency on the curve based on the k length. So we have a chart, and then you have a k on the horizontal, for example. It's gonna be the length, the frequency, and then you have the length of on the y. And what they're asking is, how is you given any k that they pass, how can you get the y? I think maybe, I'm not pretty sure. extra challenge on this one is that like I'm doing like a sub problem here. The extra challenge will be that to find all the other ones, you can delete the strings as well. So there's an additional pattern there. But I want to focus on this one first. Oh, no worries. I think I'm confusing. But maybe not. Let me think. So the way that I'm thinking about it is that this one's gonna go from 0 to the length of the thing. And then it starts one ahead of this one. So in my mind, it would always get the slice. It would always get one number and not all of them. But obviously I'm thinking about it in the wrong way. So this one, for example, it would start in 0, and then the other one, it would be 1, so you would only get this one. And then it's gonna... You would just go from 1 to 1. So I don't understand why this gets all the ones. Oh, it's because it's a nested loop. Yeah, I'm dumb. Because for each iteration of this is gonna go over, yeah. So that makes sense. So it's always like it's starting at 0 and then getting all the slices. So it is just going to the right, like I was thinking about. Hmm. So I guess it's the same thing, but it's faster because you only use one loop, and then well, obviously the question would be how is this happening here? Well, maybe that doesn't matter that much, or I want to be careful because then I'm going to like I might get too specific and then I lose on the journal thing. So this is interesting. It's really smart, I think, if it works. So like what it's doing is, instead of doing the nested for loop, it finds the indices based on the matrix, and then it loops over the indices. Damn. It's actually a genius. I wonder if it's right though. And if it is right, why does it work? Like, he's getting the, as far as I understand, he's getting the upper numbers from the triangle, from the matrix, which is a triangle. And that's gonna get all the indices that create the thing. So like, what it's pretty much saying is that the upper part of the matrix, of the triangle, that it is the upper part of the matrix, is equivalent to the indices of that will be equivalent to doing an nested for loop. So let me get this thing. I think I'm just gonna print there, just say. It's obviously interesting to me because then, like, it might change the way that I think about everything. But the thing is that I think that this probably only works, or like, it's not a generic thing that I can do for any problem. It's just gonna be for specific problems because it's gonna depend on the indices that it creates here. But it's still very interesting to see because there is the relationship. Like, there's the relationship between the matrices and nested for loops, and I think it's gonna be the same as it scales. Like, the more dimensions you have, the more loops you need to have, and then what's gonna matter is the way that you structure the matrices to do the calculations. So the more dimensions you have, the smarter you have to be in the way that you extract the information from the matrices. Yeah, the question is, how do I make sure this is right or not? What if I change here? I think it's just gonna change the dimensions. Let me see the answer here. It's an numpy function that returns the row and column indices of the upper triangular parts of a row and a column with ones on the diagonal. It essentially generates all pairs of indices. Y is less than J, restricting the indices to the upper triangular portion of the matrix. It's two arrays of row and column indices, row indices and col indices both of length. These arrays will hold the row and column indices of the upper triangular elements of the... So I think what I'm gonna ask is, why does this work? Because I do think that it works. Because yeah, I think that probably the reason why it works is because all these possible subslices of one array is like have a matrix. But why would be... I guess it's just the upper triangle because the other ones would be repeated because it's symmetrical. That's why it doesn't matter if it's the upper or the down part, I think. It's very interesting. So for here it would be the same thing. I would create a matrix of length of the string, and then I just get I would do the loop based on the rows and columns of the matrix. Then based on that, obviously I would have all the strings, I think. All the patterns here. And the question then would be, like, the remainder part would be, how do you get it if you can delete the patterns? Because I think that I don't need this here, obviously. I just thought about this because it would be easier. If I can capture how to delete and get the patterns, then obviously I have the main one. But maybe that's how you do it. Yeah, because here I still haven't thought about how to delete the characters. So, but wouldn't be the same way. No, I think it would change. Because deleting the characters fundamentally changes the other one, but it's kind of hard to think about. Like, because maybe it would be the same pattern, because the only difference is that in one instance you are appending the subarrays to the other one, and on the other one you're deleting characters, but it's the same. It's the same, but it's different actually, because you would get the subtraction. It's like subtraction and addition. So I think there is a symmetry here, and it's probably related to the matrix. I think I'm gonna need a break soon, because I'm getting tired of thinking. Oh, there is something interesting here. The biggest concern that I have is spending this much time on this one is that maybe I'm getting too deep into this one, but I think that it's probably worth it. Because I do think there is a fundamental thing here. So like one thing that it made me realize this thing here, which is very interesting, but obviously I have to spend a bunch of time thinking more about this to clarify. Because this might change the way that I do everything. Everything that involves true for loops, obviously. But the problem is that it's a lot harder to think about. That's the issue. Obviously, it's easier to think about just for looping twice. Like the thing that I'm trying to clarify is that if like when this problem, and this is my concern, because I'm gonna go into a rabbit hole and it's gonna be very difficult. Because the question now that I have is that obviously this is a fundamental pattern, so what happens with the variance of the data? What's gonna happen is that you want different indices of the matrix. Because what it's saying here pretty much, if this works, is that every time you have a nested for loop, what you can do is just a matrix, and then what matters is the indices of the matrix. So the shape of the for loop is going to be directly correlated with the indices of the matrix you want to solve the thing. And then if you get the indices, then you can do only one loop. So now what I'm trying to clarify, but this is the problem that I'm saying, is that because now I want to clarify how is this relationship formed. Like how can I clarify so I have like an algorithm in my mind that tells me how to extract, which indices I should extract depending on which problem I have. But the issue with that is that then this might lead towards other stuff, and then I'm gonna just keep going like that, and then I'm gonna lose myself on the too niche thing, and I'm gonna lose the surface. So maybe I should go back to this one first, then I try to clarify the other one. So on this one, what I want to do is just create a graph of the frequency with the length. But I do think that this is the best direction to go. I think it doesn't make sense to spend a bunch of time. I think it makes a lot more sense to just do one problem. Maybe I should just choose hard problems, because those are the ones that are going to have more nested patterns together. So I should just choose the hard problems, and then from the hard problems, I try to extract the fundamental. And then I spend a bunch of time clarifying the fundamentals. So I think what I should do like this for some time, until I have like a decent chunk of fundamental patterns. Then what I should do is the reverse, where I just get the patterns and then try to solve the problems with the fundamental patterns. It's probably the best way to go about it. So maybe initially I think I shouldn't focus on on figuring out the source code. I should first focus on the fundamental patterns. So let me see. And it's crazy how powerful GPT is. It's insane. It's only gonna get better. Kinda scary. Can generate the row and column indices for the upper triangular part of matrix without using external library. Here's Python code. Yeah, but it's just looping again. So maybe it's the same thing. But maybe not, because there might be optimizations that they do. So I'm curious to see what are the optimizations. Let's see if I can find. And it's gonna be on inside of a file, I think. I think they changed the name, so let's see if I search for his name. Yeah. So let me see if they're doing something other than a nested for loop. Yeah, I think I'm probably not gonna do this, because it's the thing that I talked about is just gonna take too much time. So, because the thing is that obviously there's gonna be the relationship between depth and surface. The more time I spend on this, the less time I have to look at the other patterns. So yeah, it's just about, I think it's probably better to just focus on the brute force simple thing first. Then from that point, once I understand the fundamentals, then I worry about getting more complex. And I'm not really sure if this is even, because I think that maybe it's just using using nested for loop to create the indices. So the only thing that would change is the language, because I think that NumPy uses C, or a version of Python that uses more C or something like that. So it's more optimal because of that. But it's not like the fundamental thing. And this is the thing, for studying these libraries, it's probably going to be better to just focus on building the stuff first. Yeah, I think once I go back to building this, then... So first I should do manually the brute force thing first, then forget about this. I think I'm just going to delete this one from here. But I'm obviously going to keep in the back of my mind, but... You should focus on the brute force thing first. Then do this stuff manually. Then once I develop something that allows me to... Makes it easier to study the libraries, then I can go over this other stuff. Because here it's just gonna be annoying. I'm gonna have to go back and forth between functions to see what's going on, so... I don't think that it makes a lot of sense to do that now. Yeah, whatever. So now I'm gonna focus on how can I find the. I think I'm gonna try to plot the relationship, but maybe it's just it's not that difficult. So the thing that I have to do is just create like I'm gonna ask ChatGPT, and what I'm gonna do is just create a bunch of random arrays, and then from the random, so the random array is just gonna be a nested array of arrays, and for each one I pass them here, and then I'm gonna try to create a plot that represents the frequency with the length. The relationship between the bigger the yeah. No, actually I wanna know first like within one array. So I'm gonna plot one first, then I do the other ones. But here, let me think about what I'm gonna do. So it's just a dictionary, I think. And then I loop over this. And the thing that I'm not really sure here, I think they're always gonna be different. So this is probably fine. So first I need to check to see. Oh, I have to think about this. Maybe it's just length. So first I check to see if the length is on here. Then if it isn't, I do this, and if it is, yeah, I think this. So I'll wrap back, then I'll think about the rest. So in a way, I think that the categories that people create is kind of like what I'm doing here. So like separating the stuff based on dynamic programming and all the other categories. But I think the reason why I don't like based on all the stuff that I saw, is that when you put the problem on a category already, then it doesn't allow you to think about like the fundamental thing. I think that's the thing. So that's what I felt when I was learning. I was watching videos based on the categories. Is that, and I think it is slightly different than what I'm trying to do. But maybe not. Maybe it's the same thing. Hey, what's up? Oh, this should be 1, not 0. I don't know though. I don't know if it's different or not. Yeah, the problem is that when you focus on the category, you're just focusing on the it's focusing on the problem. I think that's the difference from the videos I watched, and even Leetcode, because it obviously is understandable. But when you separate like this, then you focus on you already have the preconceived thing on your mind that, and this is the dynamic problem, dynamic programming problem, or whatever, or backtracking or whatever. And that doesn't focus on like why, I think. So why does this category even exist? I think that's what I'm trying to capture. I haven't done much. Almost nothing. I don't have Telegram, man. So let me think. Now what I should do is, so the length is the key, and yeah, the length is the key and the value is the frequency. So I think first I'm gonna plot with I'm gonna plot this one, then I'm gonna create more, and then I'm gonna see. Let me think about this. Maybe I should create. So if I create the nested array with other arrays, and then I loop over them, I'm trying to. Maybe I can create an algorithm here instead of doing it like this. So create a bunch of arrays that are different lengths, and then append here. So I'm trying to think about what is the best way to plot. Because I want to see the difference, like as the array gets bigger, how is the graph gonna change? But I don't necessarily want to. Maybe a three-dimensional graph, but. Let me do the one graph first, then I think about the other. So I can create a loop here. And then append this one. Yeah, I think this one is easier. Then append this one to here. I'm gonna print this first, then I think about it. But the idea is to print each one, to plot. I'm gonna plot one, then I think about how I plot the other. I wasn't thinking about plot bar. Should be more specific. So what is the name of the graph that has y, x and y? Yeah, I guess I want to find the equation. So maybe it doesn't even matter to plot. This is the stuff that I want to find, is the equation. And I think I want to find the equation because then it's going to reduce everything to the equation. So I think this is the thing. So I'm going to spend more time on this problem. I was going to... Like, the idea that I had is to do half an hour for each one. But the more that I do this, the more I like... I think I prefer much more this method of study than the other one, because it feels a lot more useful to me. So what I want to see if I can do is to derive an equation that is going to determine the relationship between the frequency and the length. So first I need to think more about... the thing is, I have to take a break. So I'm kind of getting tired. But I need to clarify exactly what's the relationship that I want to capture. Because I think that the number k is related to this equation here. The only difference between this thing here and the actual problem is that on the problem is going to be more about the... I'm gonna have to figure out how to... probably gonna use ChatGPT to not only get all the patterns, like all the sub slices from the array, but also how to eliminate the different patterns. The thing that is kind of confusing to me as well is that I'm not really sure, because like I'm not 100% sure if this is getting all possible combinations. I think it is getting all the slices though. Because the way that I was thinking in my mind now is that, like, let's say I transform the string into an array by splitting on an array of characters, then I can get all the possible slices. That would be all the possible substrings. But in my mind, it's still... I'm not 100% sure but it should get all of them. But the thing is that at each step of the process, I have to delete. I think that's the difference, because when you delete, you can get other strings. When you delete characters. So I think that... yeah, I'm probably gonna use ChatGPT, so the first one we have to delete, and I'll just get the patterns. But what I think I can do is... like, if the problem didn't have the if it didn't ask to delete some characters, what's like if I reduce the problem to this, then I think what is likely happening here is that there is the relationship between the frequency and the length of the thing, and that's the k that they want. So if I just find the equation, I can just put k on the equation, and then it's gonna be the answer. That's what I'm trying to do. Yeah. Yeah, let's run this and see if it works. I'm just gonna print here as well. I think I have to put penalty show. There we go. So it's just a linear relationship. It's obviously gonna be like this for regardless of how long is the array. So, but I think I need a break because I need to think about how this is related to the problem there. Because the thing is that it has to be repeated, so that would be the difference. But then obviously you can join the arrays and then check. Or I wouldn't even need to build arrays. I can just build based on the string, obviously, and then I can just check to see. But isn't that so? Maybe I'm not capturing the correct one. Like the correct relationship here. It's out of the ones that are repeated, so it's a different graph. Because if they have the same length, doesn't mean that they are the same, obviously. So I think the difference would be that out of this, that the ones that repeat, I would have to see if they are equal. And then based on that, create the frequency. So there's an extra check there. And then after that, then I think the relationship is correct. So maybe I should do it with strings instead of arrays, because then I want to find the mathematical thing that comes from the problem. So I'm gonna focus on the problem, and then, yeah. I need a break. I'm gonna do yoga nidra. But I think there is definitely something here. It's like, it's kind of fuzzy in my mind right now because I've been thinking for some time, but yeah. Like I just realized that as well, that the thing about the mathematics is that like all the problems are gonna be based on mathematics at the end of the day. But it is obviously different, but I think that yeah, there's a lot that you think about, to be honest. So if that is the case, then what I can do is just try to reduce every problem into a mathematical equation. And then based on the equations, I can see like what are the patterns that are repeated most often. Because it's going to be a relationship as well. That is obviously going to be very difficult. Because the tricky thing is like, how do you define? Because in each one of those things, you're going to have several different branches. That's the problem that I'm having here. So it's very difficult to know like how to draw the line. I think this is just a challenge. Because here, like the problem that I'm having now is that there are multiple ways to, because the way that I thought initially in my mind is that the fundamental thing is just to have a boundary that is an array. We call array, but it's just a thing in memory. And then you have to find the subsequences of that. But then you have to find the subsequences that are equal to each other. But then what does that mean? Is that it has to be a string, but it's going to be dependent on the data type. So I think the fundamental thing is like when you have a slice of memory, how do you figure out the frequency, the relationship between the frequency, the length in patterns in memory that are the same. That's the fundamental thing. Because the data types are going to be broken down into data, into binary, obviously. So if you're comparing different data types as well, then the only thing that is going to change, yeah, the way you compare changes the frequency, obviously, because it's related. So, and that defines the boundary of the problem, I think. So let's say, for example, we have a different problem. Instead of comparing, you want the longest one that is repeated k times, but instead of having to be like the same substring, is like a different pattern. One is a substring and one is a float. So let's say I want to find like for every situation where there is a certain substring and there is a certain float number, and then that's the pattern I want to find. So in essence, it's still the same problem, but it's different because it's a different data structure that you're comparing. So the fundamental thing is this relationship with memory. It's like the way you compare the memory is going to dictate the frequency of the thing. And then to break down all the possibilities, you have to do the nested for loop to get all the slices of that memory chunk. Then with the slices of the memory chunk, you create the relationship of frequency and length based on the whatever equality you want to do to compare the data with itself. I think I have to go back as well. Like, yeah, I'm not really sure what's the best way to go about it. Like, if I should go back and then try to see how to do it if I delete characters. Because I think this is one piece of thing that makes the problem, like, this is one of the parts of the variance of the data that is going to change the problem. Because obviously you have if you have a different type of data structure, then it wouldn't be the same to remove one part. But I think that in its essence is a fundamental. But depending on the data structure is going to change the thing. So maybe I should clarify first, like what is the like, because I do want to, I think it's very clear now in my mind, this one here is just doing like the simple approach. Just doing a loop every time that it loops on the outer one to get the sub ones, and that gets all of them. So I think that's gonna work for any. Obviously, you're just gonna change the methods. But I wanna clarify what this. I'm not really sure how to write that structure there. And that's what I need to clarify first, I think. So how will it change on this thing here if I can remove? And it's kind of confusing to me to think about. Even this one, I think I get it. Maybe I'm overcomplicating in my mind. So I think I get it. You're just like you is like first is gonna get all of them, then it's gonna decrease, get all of this, all the combinations, then decrease, gets all of this, which is what I was thinking in my mind. But like, I was thinking more from yeah, it was thinking pretty much the same, but I didn't clarify to nested for loop. But some yeah, but the thing that is kind of because I'm not 100% sure if that makes sure that there isn't like this string here and then this string. I think that's the problem. Because in this way, it's just gonna capture the ones that start at the here. I think it doesn't capture all of them. So I'm not 100% sure that this is correct. I think that's the problem. It's just gonna get all of. Actually not, because then the slice change, so it is gonna like the start changes and then it goes again. So, but maybe not. Maybe not. So in what situation you would get this one? This slice here. It would be like when the start is at 2 and the end is at 1. So it does get all of them. It's just that it's kind of confusing to think about. Yeah, I think it does get all of them. So now after I clarified this one, then I'm gonna go to the other parts. I think once I clarify this, and then I'm able to capture the relationship between the frequency and the length of the repeated ones, then I think I'm gonna move on to the next one. But I'm gonna do this yoga nidra thing here first. Yeah, I'm not really sure if I'm gonna go because I do need to rest. So, I think I'm gonna try to go for 1 hour more, and then I'm gonna stop streaming. Maybe a string later. I want to keep going, but the problem is that like I get tired and then I can't think anymore. So there isn't anything that I can do. So I'm gonna do this thing here, and after that I'm gonna continue the other stuff. So I think I'm gonna keep going for 1 hour. I'm just gonna do this stuff here.
Welcome to the
I'm gonna continue to do this, so let me think. One thing that I don't like about these problems is that a lot of times it's very confusing. Like exactly what they are asking you to do. And I guess like a lot of the times it's just the nature of the thing. It's kind of hard to explain and clearly what you want without giving any hints. It's repeated 2 times in the string. So it's eliminating characters and then forming a substring, and then finding a substring within that string. That is repeated 2 times. So I'm trying to think about this to formulate a question to ChatGPT to see what it's gonna come up with. It's like it's very similar. The only difference is that you can remove characters. But like, what would that mean? Because you can build other arrays from the original one based on like the different. I think the biggest difference is that the arrays, like, it would be possible for the arrays to not be continuous, let's say, or to like. That's, let me think. The difference is that it allows the possibility to create other arrays based on like one level of the array by eliminating certain characters. Yeah. Obviously, it's easy to think about the like one specific case, but it's very hard to think about all possible ways. So how can I ask this to ChatGPT? Maybe I should just ask the question directly. To get all possible substrings of a string, including those formed by eliminating any amount of characters. Cursor approach. So let's yeah. Uh, yeah, my first instinct is that this is not correct. So this is the substring, and this is the big one. Because the thing is, I don't understand why the I hash should be equal to the length of the string here. So it's just adding the characters. Oh, this one. I mean, maybe it is correct. I think that's uh, first it doesn't seem like it makes sense because you're just adding the characters, but because it's recursive, it can be like maybe I'm being confused. Else here you're just gonna add the characters to the empty string until it reaches the index of the other one. And because there is only this condition, I think that is always gonna hit this one first, so until it reaches the base. But maybe when it backtracks, it hits this one. Yeah, recursion is very confusing to me. I think one of the biggest things that I have to try to become better at. So it does work. I think it's because when it backtracks, it goes to this one. I mean, maybe if I put a breakpoint here. Right here. And that's what I was imagining. Then when it's gonna backtrack, it's gonna go hit this one. But it is very confusing. Yeah, because the first it appends the original string, because it's just adding the same characters. But then when it backtracks, I think that I will go here. But yeah, it doesn't make a lot of sense. So after he hits the base case here, he's gonna call here. And then for each one he calls here, he goes again here. Maybe that's the reason why it works. It is very confusing though. So like as this one is decreasing because it's going back the stack, this one is increasing the thing. So it works like a symphony. And it's going back and forth, obviously. It's very difficult for me to think about. I'll definitely not come up with this like the first try, so. I think to solve the problem, the only thing we would have to do is put the cache there and count the frequency. But obviously I don't care about that anymore, so. And the problem with this one is that it's not very clear to me how I can use this with the other one. I don't need the cache, I can just loop over this thing here. But I would put the cache outside and then I will loop over and do like a counter to increase the frequency. Yeah, I think what I'm trying to clarify is the relationship between this one and the other one. And that's why it's hard with this solution, because it's not clear to me how I can go from the other one to this one. The way that I originally thought was by breaking down into two parts. So I'm trying to think about if I was gonna break down, maybe this is the question that I can ask. Because from these points there, I think that all you have to do is just loop over and then do the counter as I said to find the answer. No, now I think that it is different. I still need the other one because now I would have all the substrings from the other one, but I still need to count the patterns. So I think it's two different things. I'm conflating the two. So this one is just the one that you have to do in the beginning, and then based on the substrings you loop over them, and then on the substrings you find all the. But is that the same? It is the same because then it's not only finding all the possible slices of that string, is figuring out which ones are equal. So. Yeah, so I think that they are separated, the two parts. So let me see. I'm gonna put the whole problem in ChatGPT. It's probably gonna know like which one it is, and let's see what solution it comes up with. Yeah, I think now what I should do is just focus on like, let me think. What would be the difference? I think the difference between one way the other, like one problem is just this part of finding the patterns. If it was not possible to delete the characters to get substrings, then the problem would be just to find the patterns, like find all the subslices on the string. But I guess so. Maybe what I can ask is for ChatGPT to convert this into a recursion, because if both of them are on a recursion, it's gonna be easier. Because this is the thing that I'm thinking about. Like if this one can be done with this recursion here, the other one should be possible to do with the recursion as well. Because it should be fundamentally, like it should be very similar, both of them. The only difference is that one, you're eliminating strings, eliminating characters, and the other one is just the main one. So that's the difference, I think. So it is kind of the same. And then from that point, on both of the situations, you need still to get the... You still need to compare the results you get, which would be all the subslicers or substrings, to see which ones are equal to each other. So I'm gonna ask how to translate the other one. Oh, so yeah, I don't understand. Oh, the difference here is the loops, though. So here it's going backwards. But I don't understand how this is possible, because it's not taking into account that you can delete characters. Let's see if it works. So this is the thing, maybe I misunderstood the description there. Yeah. So I think that this is not correct, because one is not taking into account that you can delete characters, and the second one is not counting anywhere the frequency. Well, it's counting to see if it is k, but not how many times the string shows up. So maybe it's just ChatGPT hallucinating or whatever. Or maybe not, because this is like it's supposed to count how many times. But this is the thing, is that it has to be the one that is repeated the most, I think. Oh, is repeated, is the one that should be the longest. So maybe the loop gets the longest, but that wouldn't make sense as well. So I think what is missing here is that there should be a check to see about how, like, you have to check all the strings to see. So from here, instead of returning, you should probably append somewhere and then check the length. So maybe not append, it should just create like a previous or longest. And then here you make it equal. Now let me think. Let's see if this works. I have to return final. I don't know if this loop makes sense though. I don't know. So I think I'm gonna stop here because I'm already really tired. And I wanna think about, like, the thing is I wanna keep going, but I'm already very tired. So I have to eat something and then just like rest for some time before I can keep going. And what I wanna do, I think this is a good strategy. So probably what I'm gonna do is go back and forth, because I do wanna improve on algorithms. But the thing is, I don't like doing Leetcode that much, but I think this approach is probably the best for me. So what I'm gonna do is just go back and forth between doing these problems like this. So I'm not gonna worry about solving the problem, I'm just gonna worry about finding the fundamental problems, fundamental things about the problem, then trying to figure out if I can create like a template that captures that fundamental thing, and just each time try to clarify more in my mind why the fundamental thing exists and how we should approach the problem, like thinking about that already. So what I want to do here is, like, for this problem, I think the fundamental thing that I'm getting out of this is that I'm still not very clear. I have to spend more time thinking about this part here of when you have to delete characters. But for me, when it comes to this part, the fundamental thing, if you want to find patterns inside of a string, if you want to find the one that happens most often, or like the relationship between the one that happens most often or the longest, what you have to do is to, like, this is gonna be the essence of the thing. You're gonna have a boundary, which is gonna be a slice of memory, and then inside of that you're gonna extract all possible chunks by doing this for loop, which is related to the matrix there, the indexes of the matrices, like ChatGPT says. I think that makes sense. So to get all the possible combinations, the amount of loops you're gonna have to do is gonna be directly correlated with the dimensions of the data you have. So if you have a, and I think that's how it's gonna scale. So if you have an array, it's gonna be one dimension, and it's gonna be 2 loops. You get all possible combinations that exist within the boundary. And the more dimensions you have, the more loops you have to capture all the possible combinations. Once you have all the possible combinations, then you compare. Then there's going to be the relationship between how long it is the combination and how the data type of the structure, and that's going to depend on which essence you want to capture. So if you're comparing strings with itself, you're just going to compare the same data structure with itself, and that's going to dictate the frequency, and obviously the length is going to be based on the first step, which is just getting the slices. And this is the fundamental thing. But I need to spend more time clarifying, because I know that's, I'm thinking about that now, like there's a more general thing here that I can capture, which is probably going to be a mathematical function or something like that. That is going to happen all the time with these problems, I think. But it's kind of hard to grasp exactly what it is. So I want to come up with, like, I want to clarify in my mind, like, every time that I approach a problem like this, how should I think about it? What is the best way to go about getting the specific slices and getting the frequencies? Then once I figure that out for this one, then I think I can go to the next one and see if there are other patterns. And the biggest thing that I want to clarify as well is the recursion. I need to figure out a way to think about. I want to do the same thing that I'm doing this for this one for recursions, because I know that there is something there as well. But yeah, I'm gonna stop here. Maybe I'll come back today, later on, to do another one. But I have to take a break. If I don't, I'm gonna come back some other time, and maybe next time I'm gonna continue to work on the website there. But I think I'm gonna go back and forth between the two on building this website and doing the Leetcode, because I think that they're gonna be synergetic, like they're gonna help each other. So doing the stuff manually is gonna allow me to clarify in what ways maybe I can create the compiler to parse the code and extract the information. That's the goal. The goal is to automate this process, obviously. So see you next time.